Hello viewers, my name is Ishan Akbar. In this video lecture, I would like to discuss the grades of concrete and water cement ratio required for the various grades of concrete. So this lecture is basically a summary for the grades of concrete and water cement ratio. Before proceeding with the lecture, I would like to request all of you to please subscribe my channel if you have not subscribed till now and press the bell icon to get my newly uploaded videos. Thank you very much. So let's proceed with the lecture formally. So first of all, we have to know that what the grade of a concrete means. So simply whenever we see the grade of a concrete written over any page or over anywhere, so simply we see like these numbers and letters. So simply we can say that the grade of a concrete sample or a concrete specimen or a concrete batch is a combination of letters and numbers. So here you can see the M5, M7.5, M10, M15 and M20 written without any space. So whenever you see these numbers M, a letter followed by a number. So simply you can say that this M and 20, this M and 50, 15, and this M and 10, M and 7.5, M and 5. So simply you can say that this is a grade of concrete. So how can we justify this letter M and a number 5? So simply you can say that this M means for the mix of concrete. So simply you can say that this M stands for the mix ratio of concrete. So what is the mix ratio? I will let you know on the next page, but here you can just understand that mix ratio is basically the ratio of constituents of the concrete except water. We will not include the water in mix ratio. That is another thing that is known as water cement ratio. I will let you know also the water cement ratio at the last of this video lecture. So simply mix ratio is the ratio of cement, sand and coarse aggregate. Simply you can see that say that the ratio of parts of the cement required for a grade, parts of sand for required for any grade of concrete, and parts of coarse aggregate required for the preparation of a specific grade of concrete. So we can say that a mix ratio is different for every grade of concrete depending upon the strength. Let us suppose we have a M5 grades concrete. So mix ratio means parts of cement, sand and aggregate will be different for M5 and they will be different for M7.5. They will be different for M10, M15, M20 grade concrete. So, what is meant by these numbers? We have understood about M that this is a mix ratio of concrete. So, we have to design a mix ratio whose number will be 5. So, what will be this number? Simply, we can say that these numbers 5, 7.5, 10, 15, and 20 simply show the characteristics compressive strength of concrete cylinders. So, simply, this is the cylindrical strength of concrete grade. After how much time? After 28 days. So what will be the unit of the strength? It will be in megapascals or it will be in Newton per square millimeters or per millimeter squares. So it can be in either unit. It may be in megapascals or it may be in Newton per millimeter square. So this M stands for the mix ratio and this letter stands for the compressive strength of concrete cylinder after 28 days. Mean you have to cast a cylinder and you have to test that cylinder in universal testing machine for its characteristic compressive strength after 28 days. Because why after 20 why do we check the compressive strength of concrete after 28 days? Because we accept that and it is evident from the laboratory testings that after 28 days concrete attains its 99% of the strength. So simply, you can see here, this is a concrete cylinder. I have specified this here that this is the cylindrical strength written over here with the grade. It is not the cubical strength because we oftenly we check the cubical strength, but that is not written over here for the grade of concrete. For grade of concrete, the letter M stands for mix ratio and the number stands for the strength of concrete in megapascals for cylindrical samples after 28 days. So if you are clear about these concepts, then we can move forward to the mix ratios of various grades of concrete. So if we have a specific grade of concrete, then we will have specific ratios of cement. This C stands for cement parts, this S stands for sand or fine aggregates, and this A stands for coarse aggregate or simple aggregates. So if we have M5 grade cement, FM5 grade concrete, it means its strength is to 5 megapascals. Its cylindrical strength is 5 megapascals after 28 days. So what will be its strength? Its content of cement. So always for every grade of concrete, the part of cement will be one, but part of sand and aggregate will change according to grade of concrete. So commonly, this sand the parts of the sand are half as compared to the parts of aggregate or coarse aggregate. Simply, you can say that uh, fine aggregates are half of the coarse aggregates, or you can say that coarse aggregates are the double of fine aggregates. Mean A is the two times of S. Here you can see that there is one part of cement, five parts of sand, and 5 times 2 is 10. So 10 parts of aggregate. Sorry. For the same instance, I want to obtain a grade of concrete whose strength will be 7.5 megapascals, whose cylindrical strength will be 7.5 megapascals after 28 days of casting. So means I have to decide a mix ratio for this grade of concrete. It will be 1, 4 and 8. So we can see that as we are going to increase the strength of concrete, we will have to decrease the contents of sand and aggregate. It is reduced one by 1 point, and this so simply we can see that this 8 is the 2 times of 4. When we multiply this 4 by 2, then we will get this 8. So simply this parts of aggregate is double the parts of sand. So if we are going to obtain the M10 grade concrete, then it will be 1 ratio 3 ratio 6. Simply we have reduced number 1 and multiply this by 2, then we will get the parts of aggregate. And for 15 grade, we have decreased further one number from 3 and it is 2. So now the cement part is 1, sand part is 2 and aggregate parts are 4. For 20 grade concrete, we have reduced this a half, say only half number. So we will increase the strength from 15 to 20. The sand component will be reduced from 2 to 1.5 and aggregate component will be reduced from 4 to 3. So simply if we multiply this 1.5 by 2, we will obtain 3. So simply the aggregate part is the double of sand part. For M25 grade concrete, we will have a mixed ratio of 1 part cement, 1 part sand, and 2 parts aggregates. So if we can see larger grades of concrete as well, like M30, M35, M40, M45, M50, M60. For those grades of concrete, you must design the mix ratio. We don't have fingertip rules for the mix designs for the grades of concrete whose grades are more than 20, M25, but we have to design on the site or according to the required strength of the concrete. So this is the water cement ratio for various grades of concrete or amount of water which is required by a specific grade of concrete. So at the first instance for M5 grade concrete we have to get a strength of 5 megapascals. For this 5 megapascal strength we have to use 60 liters of water per 50 kg of cement bag. In Pakistan, we normally have, in the world, we normally have weight of a bag equal to 50 kgs. So for 50 kg bag, if you are going to obtain or you are going to prepare a mix for 5 megapascal strength, 5 megapascal cylindrical strength after 28 days, then you have to use 60 liters per 50 kg of cement bag. If you are going to prepare this strength, prepare a concrete whose strength will be 7.5 megapascals after 28 days, you have to use 45 liters of water per 50 kg of cement bag. It means uh, we are decreasing the content of water with the increasing strength of concrete grade. So for 10 megapascal concrete or M10 grade concrete, we will need 34 liters of water for 50 kg of cement. For M15, we will need 32 liters of water for 50 kg of cement. For M20, we will need 30 liters of water for 50 kg of cement. And for 25 grade concrete, M25 grade concrete, we will need 25 liters of water for 50 kg bag of cement. Means if you are working on a batching plant and you are going to prepare 25 grade steel with a strength of 25 megapascal and you are going to utilize hundreds bags of cements, 100 bags of cements, it means that you are totally going to use 5000 kgs. So simply you will divide these 5000 by 50. So simply how much liters of water will be required? That will be 100 liters of water, because for for 50 kg you require 25 liters. Oh, sorry, 100 times 25. So simply we will need 2500 liters of water. 2500 liters of waters for the preparation of 100 cement bags, because each bag weighs 50 kg, so total weight of the bags will be 5000 kgs, and we will divide by 50, so we have 100 bags. For each 50 kg bag we require 25 liters of water, so simply we will multiply this 100 bags with 25, so we will need 2500 liters of water for the preparation of 20 M25 grade concrete with cement bags of 100 numbers. Thank you very much. If you are not subscribed my channel till now, you have to subscribe, like my videos and share with your friends. See you soon with the next video. Till that time, take care. Allah Hafiz.